Hello and welcome to the video. This is a quick overview of how I've put everything inside this model here. Now this is the Mars plane. This is one that I've had for a little while and I've been using it to put iNav 5.0 in. Now I'm recording this before I made the plane, so hopefully it's still going to be in one piece after that particular exciting event. But I thought, while I have the opportunity, let me show you how to put the electronics in. Because so far in that series, I have really been focusing on how all the pieces fit inside. And one of the things I haven't talked about is how the DJI system is installed in there, because I've put DJI HD in this particular one, and how all the cabling works. And I want to kind of talk a little bit about the cabling from the DJI system into the flight controller, particularly as one of the patrons recently was having trouble with that. We ended up having a phone call to try and figure it out. It is not as difficult as it sounds, but it's worthwhile me covering just so it is crystal clear. Because in the series so far, I've been using a TX16S radio with a standard little receiver, and that setup has been going great. However, I've swapped it over now to the DJI HD system because that's what I intend to fly with it. And that works great because I have the HD FPV controller from DJI that actually connects the air unit and is the radio, and I'm flying that system as well. So let me just show you how all this has gone together. So if you're interested in building one yourself, or just like looking at how other pilots put this stuff together, I'll show you right from the front all the way through the back and talk about all the different parts that I've used too. So the first thing just to take a quick look at are the wings. Nothing interesting here at all. I put the covers over the bays out here, which are designed for VTXs and other things. CG mark is molded into the wing, which is nice. I'm going to use that for the maiden flight. And obviously this here was probably originally designed for some kind of clever connection system. Now I have got in a bag of connectors that potentially could work, but I haven't installed them because all that's out there is actually the servo. So I'm not too worried about that. I can just make a servo cable that I can connect and disconnect. It is such a shame that they took the time to design that into the balsa wood and then didn't do anything with it. But apart from that, nothing else is different. Put a couple of decals on. There's no leading edge protection. Nothing to really write home about with the wings at all, really. It's the body where I've made a few changes. Let's start with the nose and the FPV equipment. Now the overall weight of this model with this battery inside in flying condition is 1.45 kilograms. So it's a reasonably heavy model, but it has quite a large wingspan. So the first thing you'll note at the front is there are two noses that come with this thing. There's this one that's pre-built, which kind of has a cutout. Hopefully the camera's picking that up. In fact, I can pick it out with my thumbnail. There we go. Both of them have a cutout. One of them comes pre-built like this, which has the kind of regular pointy nose. Loads of room inside. And there was another one in the box, which is the one I'm using here. This came unassembled, and I have used it here. And as you can tell, I've fitted the DJI HD system. I'll give you a closer view of that in a moment. I've made this mount so that the camera can be connected here. Gives me a little bit of latitude up and down. The reason I've used this one is because it was designed for a camera to go here. However, that gives me a little bit of airflow that goes over the air unit. The reason that the air unit is here is I really struggled to get the central gravity in the right place in this particular model. Even with a relatively heavy battery like this, I was struggling. And also with a model like this, I don't like the battery too close to the air unit. In the event of a nasty crash, the battery slides forward and slams into the back of the air unit. Now the air unit itself is actually held in here on a two-piece plastic thing that I designed and 3D printed. The rear piece fits inside here. Hopefully you can see that okay. It's actually designed on the bottom part of one of the adapters that normally slides into this front piece. There are two in the box. This one is designed for your kind of run cam, so it kind of goes out the front. This kind of shape at the bottom is what I actually designed that for. So there's the rear piece which goes inside, which the rear part of the air unit is on. And there's a front piece as well that holds the front part of the air unit in place. Hopefully you can see that okay. Now it's held in place with 2 M3 screws that go through the whole thing, and it's held in place with a good chunk of Gorilla Glue as well. So hopefully that isn't going to go anywhere. The other thing you probably noticed as I turned it over there is the antennas for this aren't the standard kind of little lollipop antennas that you tend to get with the DJI stuff. What I'm actually using here, if I turn it over, these are AeroPod antennas from Menace RC. So these are left-hand circular polarized, which they need to be for the DJI system. They're perfect for this application. I kind of like these, I must admit. There's a reason for that. I actually thought of these and pitched them to Greg at Menace, and he's made them. What's inside here is one of its pagoda antennas that's very good, with kind of an aerodynamic cover. Now, they're on the underside, and they're nicely angled in this particular way, so that it's flying overhead. I have a nice view of both those antennas, and I've got the antenna extensions again from Menace RC running from the back of the air unit into those 2 antennas. Now let's just quickly weigh the battery. In this position I'm getting perfect CG, but this battery is pretty heavy. Let me just give you an idea of the weight, just so if you're following along with this build you've got an idea how heavy everything's going to be. I could probably get a battery with more milliamp hours. There we go. So it's about 402 grams. It's about 400 grams for this battery that's in the nose, and that is, so the weight of this itself is just over 1 kilogram without anything else. Now the way I'm using this is you can see there's a ton of wires running up the back here. Now these wires go into the flight controller and coming out the air unit. There are 2 wires for power, and I use these little JST plugs for the power. That means I can disconnect the air unit when it's sat there waiting for a GPS lock, because obviously there is going to be airflow from that little hole at the front. And also the only other thing I had to do as well is, by default, there isn't a lot of room around here. I had to actually open that up with a Dremel so that it would fit centrally. It's not a great design at the front of this for a HD systems. I think that the guys behind this plane could have probably done a slightly better job for that, but with the adaptions it seems to work. Out the back of the air unit, if I can get this front back on, there we go. There are 2 wires that go into the flight controller. We'll see those in a second. And then there are 4 other wires. One of them, the black and white one, is the S-Bus. Now I'm flying this with a DJI FPV controller, which is like their radio goes along with the system. This actually connects to the air unit using the same antennas, and S-Bus goes out to control everything. So I've connected the S-Bus output from this, but you'd only connect the S-Bus output from an air unit if you're using one of those FPV controllers. If you're not, then you just power it with the S-Bus receiver of your choice and just connect the other 2 wires that come out here, which is a receive and transmit pair that is being used for the on-screen display, so that iNav can put that onto the DJI system. The only other thing I've done here is I have, with the spare one of these that was for another action camera that I'm not using because I'm using the DJI stuff, I've actually blocked this door up just for airflow, so that there isn't a load of air going into the back. I'm going to fly with a Barrow initially, and we'll see how we get on. Then in here, this is the piece that you've seen in lots already. If you're not following the series, go and check it out. This is how it all works. So here's the cables coming from the air unit at the front. Let me zoom in a little bit to give you a better view. So of the cables coming from the air unit, this red and white one are actually connected to the UART, and I've set that UART for the DJI on-screen display. Then we have the black and white cable that are twisted together going into the S-Bus input. That is going to be where my controls are coming from. And the last one that goes into this second output back here that would normally be connected to another speed controller is the power. And the reason I do it this way is that the air unit does pull quite a bit of current when it's actually working, and I also want that current to be tracked by the iNav system. So it comes out of here, powers the air unit via that JST plug that I can unplug, and away we go. The rest of the connections are the same. All of the servos are here at the front, and then we have the GPS, which is just here out of shot, and then we also have the buzzer, which is down here actually connected on this cable. But this is absolutely tons of room. The other mod that I have done, the other 3D printed part, is I've made thumb screws that go into the wings. By default, they don't provide thumb screws. Massive oversight again, come on. These are just the regular screws, and what I did is I kind of cut the tops down. I made this 3D printed circular part that goes over the top, and that makes the wings a piece of cake to take on and take off. The things shooting backwards, we have the 2 servo controls going for the V-tail, and we have the GPS. GPS is here. I cut the top out of that, so that is sitting in here nicely. And behind that then is the ESC, and that's the one that has a little bit of airflow, just held in place with the cable tie that came with the kit, and that has a cover that protects it all. Only one last thing to talk about at the back of the model, and that is the prop. I always get lots of interest in the prop that I use. This is a folding prop. This is Aeronaut stuff. So this is a 38mm central hub, and this is the same spec of hub. This is a 10 by 7 inch prop. The only other thing is there are 3D printed guides on this to stop it opening too much, and also to stop it closing and the tips smashing into each other. So that is the last bit of 3D printed goodness that's actually on this model. So there we have it. That is how it is built. Hopefully it's going to fly well. Fingers crossed. The Maiden is going to go nice and smoothly. The iNav stuff is set up as well as I can get it, and the installation looks pretty clean. So hopefully it's all going to fly. So I'll see you at that part of the series. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organized into easy to follow playlists that, if you're trying to learn a topic, will take you from the basics right the way through to some pretty advanced stuff.